So total traction force will be the summation of all the obstacle force which is acting on the vehicle when it tries to move. The first obstacle force is the gradient force. The second obstacle force due to the rolling resistance. The third obstacle force is due to the air drag, and the fourth obstacle force due to the linear acceleration as well as the angular acceleration. So what I did here, I just replaced force with torque of the wheel divided by the radius of the wheel, and then I wrote the formula of respective force. So for gradient force will be mg sine theta plus the rolling resistance force will be mu r mg cos theta plus the drag force will be half rho into frontal area of the vehicle multiplied by the drag coefficient and multiplied by the square of the speed of the vehicle. And here I am replacing the total acceleration force with ma, and here the mass which I have taken is the mass of the vehicle, but if we want to take the account of angular acceleration force, we will simply increase this mass by 5%, but for simplicity I have taken just the mass of the vehicle here. So let's go forward. So here what I did, so instead of writing the wheel torque, I wrote in terms of the motor torque multiplied by the gear ratio, and then the gear is also having some sort of efficiency, and hence I have multiplied by the gear efficiency here. And the denominator remains the same, and then everything else remains the same except the end, where I have replaced this acceleration with rate of change of speed of the vehicle, which is dv upon dt. So the next what I did, I wrote this expression in terms of dv upon dt is equal to torque of the motor multiplied by gear ratio multiplied by the efficiency divided by vehicle mass into radius of the wheel minus mg, which I have taken common, and here as you can see in this bracket I have written sin theta plus mu r cos theta minus 1 by 2 into mass of the vehicle multiplied by density of the air multiplied by the frontal area multiplied by the drag coefficient multiplied by the speed of the vehicle. So here we got the differential equation, and if we solve this differential equation, we will get velocity or speed of the vehicle in terms of function of time. That's what our overall aim is to calculate.